right, good morning, Group A students. We're going to go ahead and start our bell work today by demonstrating why a squared plus b squared is not factorable over the real numbers. Real numbers are anything that you can count. So fractions, decimals, integers, those are all real numbers. We talked about yesterday how we can factor a squared minus b squared, but we're going to demonstrate why you cannot factor it if it's a sum, why we didn't have a rule for a sum of perfect squares. And how we're going to do that is just different cases. If I give you two factors, a minus b and a plus b, and ask you to FOIL them, let's see what we get. So if we FOIL, a times a is a squared, a times b is ab, negative b times a is negative ba or ab, whichever one you want to think about, and negative b times b is negative b squared. Then if I simplify that, ab minus ba, that makes 0. So we're left with a squared minus b squared. Well, that wasn't a sum, so that does not equal a squared plus b squared. So that case proved that that did not make this a squared plus b squared. Okay, let's try another set of factors. Let's try both negative ones, see if that works. A minus b and a minus b. Let's FOIL those again. A times a is a squared. A times negative b is negative ab. Negative b times a is negative ba. And negative b times negative b is positive b squared. Again, we're going to simplify this. A squared, negative ba and negative ab, those can combine to make negative 2ab. This order of ba and ab does not matter. It's the same thing. Plus b squared. Well, I can't simplify that anymore. And if we go back to our original question, that does not equal a squared plus b squared. So that case didn't work. Let's try one more. So we tried a negative, a positive, a negative, negative. Let's try a positive and a positive. A plus b. Let's FOIL those. A times a squared. A times b, ab. B times a, ba, or ab. And then b times b is b squared. Okay. Now I'm just going to simplify this a little bit more. A squared, that does not combine with anything. So I'm not going to combine it with anything. I'm just going to bring it down. AB and BA make 2AB. And B squared, that just comes down as well because it can't combine with anything. Well, that case didn't work any way because it didn't make A squared plus B squared. Okay. As we look at our options, we had two positives, two negatives. We had a minus and a positive case that we considered, and none of those worked. If you think about the last possible case, you could flip that order of the first one, A plus b, and then a minus b. But because of the commutative property, this case, that I could flip the order, and it's the same thing. 1 and case 4, those are both going to get us the same thing. So neither of those equal a squared plus b squared. As we look back at all of our options, none of them made a squared plus b squared. So that is why this is not factorable over the real numbers. So on your test, I'm going to give you guys space to write this, but this is the type of question and this is the type of work I'd want to see. Today we're going to go ahead and solve equations by factoring. We factored this past week on Tuesday, and on Thursday we learned about factoring. Now we're going to actually take it a step further and solve equations. Before we can find the solutions to a polynomial, we must set it first equal to 0. So you must make it equal 0 first. Next, we can factor the polynomial. So we're going to factor using one of our rules or methods we learned this week, and set each factor equal to 0 and solve. So I'll demonstrate what I mean by all these zeros. So solve the variable by factoring each expression. So as we look at our first example, p squared minus 49 equals 0. Well, as we look, these are binomials. Thinking back to our previous slide, we need to set it equal to 0, which it is, so that's good. And now we can factor. P squared minus 49 is a difference of perfect squares. So I'm going to factor just like I did on Thursday. Square roots, square root. P in each of them, 49, square root of 49 is 7. Put plus and minus in between, still setting it equal to 0. Now because I'm solving these, I've got to take each piece. If I know that the product is equal to 0, this could be 0. Or this second factor would multiply to be 0. Remember, 0 times anything is still 0. So I'm going to take each piece of my factor and set them equal to 0 to solve. So I'm going to subtract 7 from both sides of the first one and get P is negative 7. And I'm going to add 7 to both sides of the next factor and get P equals positive 7. And those are your two solutions. Factor and set each piece of your factor equal to 0. Let's try the next one. Solve the variable by factoring each expression. Again, whenever we're solving, we need to set it equal to 0. So I'm going to add 24 over here to make this equal to 0. 10m plus 24 equals 0. Okay, first step done, equal to 0. Next step, this is a trinomial. Remember your steps, check GCF from Friday or Thursday. We talked about factoring trinomials, check your GCF first. This does not have a GCF because there's no factors they have in common and they don't all share an m. We see though that there's a 1 in the front here, so I'm going to find two numbers that multiply to make 24 but add to be 10. Once you come up with your factors, multiply to make 24, 6, and 4, and those add to make 10. And they're both going to be positive, so they multiply to make positive 24, and they add to make positive 10. And then we set that equal to 0. We're going to do the same thing we did on the last one. Split the factors apart and set them equal to 0. Minus 6, m equals negative 6. And minus 4 from both sides, m equals negative 4. And those are our two solutions. Let's try another one. So we look at this example C. It's a trinomial that's set equal to 0, so that's good. Trinomials, check the GCF first, and then we can choose what factoring method we need to use. This does not have a GCF, but we can use a special method because there's a 3 in the front. Do you remember from yesterday what it was? Right, it was called slide and divide. So I'm going to take the number that's in the front, slide it to the back. 3 times 8 is negative 24. I'm going to factor this piece because there's a 1 in the front. I can factor it. X's go in the front. What multiplies to make negative 24 but adds to be negative 2? Those two integers would have to be positive 4 and negative 6. Right, those multiply to make negative 24, they add to be negative 2. But before I can set this equal to 0, I have to divide. Remember, slide and divide. This 4/3 does not reduce, so 3x plus 4 is what I end up with there. 6 divided by 3 is 2. And now I can set it equal to 0. So I'm going to say each factor, 3x plus 4, equal to 0, and x minus 2 equal to 0. And just solve each of those for x. So as we look at this first one, I'm going to subtract 4 from both sides. Then I'm going to extend the page a little bit so we have some more room. 3x equals negative 4. Divide by 3, and x equals negative 4/3. Okay. Next one, I'm going to add 2 to both sides to that factor, and x equals 2. Those are my two solutions, negative 4/3 and positive 2. Let's try another one. 4x squared plus 16x equals 0. We're solving, so it's set equal to 0, which is good. We've got two terms, so this is a binomial. First step is check the GCF. You always want to do that first when you're factoring. So 4 and 16 have a common factor of 4. They also have an x in common, so I'm going to pull out an x and divide by 4. 4 divided by 4 is 1. X squared, pull out 1x, you're left with just an x. 16 divided by 4 is 4. Pull out an x, so I don't have an x there anymore. Still equals 0. Now that I factored, x plus 4, that can't be factored anymore. So I'm going to split it apart and set equal to 0. X plus 4 equals 0. And just solve. Divide by 4 on both sides. X equals 0 for my first solution. Subtract 4 to both sides. And x equals -4 is my second solution. Okay. That was just factoring with a binomial and solving them by setting them equal to 0. Let's try one more problem just to make sure we're all okay on these solving by factoring problems. It says x cubed plus 2x squared minus 18 equals 9x. Remember, if you're solving, this has to equal 0. So I'm going to subtract 9x to move that over to the other side. It's 2x squared minus 9x minus 18 equals 0. Okay? Well, if I look on that left-hand side, this is a cubed, whoops. As I look on the left-hand side, I can tell that there are no greatest common factors, but there's also 4 terms. Remember from Tuesday, we talked about if you've got 4 terms, we use grouping. That was another factoring method. So x cubed plus 2x squared. Pull out their GCF of x squared. X cubed, pull out x squared, I'm left with x plus 2. On my next one, -9 and a minus 18. Because there's a negative in the front, I'm going to pull out a -9 out of both of those terms. -9 divided by -9 is 1x. -9 divided by, or -18 divided by -9 is positive 2. Set equal to 0. Because these inside pieces match, I can group the outsides together. X squared minus 9 and x plus 2, still setting that equal to 0. Okay, but as we look back at this first factor, x squared minus 9, we can factor that some more because that's a difference of perfect squares. And we know how to factor that from Thursday. So I'm going to take the square root, x, and the square root of 9 is 3. Put plus and minus in between. And then I'm going to still bring down that x plus 2 because that was part of my factors as well. And set equal to 0. Last step, because I factored everything, we're going to set each piece equal to 0 and solve. So take each of your factors, line them up across, and set them equal to 0. Then subtract 3 from both sides to get x equals -3 for my first one. Add 3 to both sides to get x equals +3. So there's the next solution. And subtract 2 from both sides to get x is -2. That's my last solution. So 3 solutions.